If game development feels like a mystery to you, if you find it exciting to be able to create a game, if you're just starting out in game development, or if you're just at the beginning of your game development journey, this video for you. Watch this video to the end and you will definitely be surprised. By the end of this video, you will realize how easy game development is.
We're going to write the famous game called Pac-Man together. You've probably played this game at least once, and this is a simple version of the game. But to get started, you just need a little knowledge of HTML and JavaScript. After finishing this video, you can develop the game yourself, add new phases to it, and enjoy these changes. So let's get started with writing the game. Let's dive in. For your convenience, I have prepared some initial assets and basic code. You can clone them from my GitHub, the link to which I have put in the description. You can clone from the Anything branch. I have also put the repository link in the description of this video. In that branch contains the final code of the project. So be aware that if you want to practice, you should definitely use the init branch. After cloning, I select the Anything branch. Now, I run the following commands: yarn install. Then I run yarn start. You can use npm instead of yarn. Now, our project is running. We click on this link and see the initial output in the browser. Now, everything is ready for the live full coding experience. So beginning video, well, we see a few files and folders here. Let's quickly review them together. We have a soundsy folder where we've put all the game sounds. Now, actually see an image named background.jpg, which is for our game background. We see a very simple HTML file, which is the initial code of our page that will be connected to JavaScript via DOM. We see an index.js file where we are going to write most of our code, and one of our most important files, setup.js, where all the constants of the project, like our game ground matrices, are located. So until now, we have understood the initial codes that I have prepared for you. Let's write some code. In the first step, I need to go to the index. That's why. From the setup file, I need to import the following values into the project. I need to add our DOM elements, so started adding the DOM elements one by one. Game rig is where my game field will be drawn. Score table is supposed to show my scoreboard. And for now, the start button is my start button. My game has 3 levels, and I use a combo box to select the levels. So I add that to this. I need to add listeners so I can track the change of levels. So I write the code as follows. Before this, I define game board at the top. So now we need to define the selected value on the project. So I added at the top. I'm saying that by default, the easy level should be selected. Now let's set up the constants for the project. Initially, I write that my build time to 1000 milliseconds, which is the time that my Pac-Man character can eat ghosts. My global speed is 80 milliseconds. Now let's move on to our own variables. So I write that my initial score is 0. I don't have initial timer. I'm not a winner. The pill is not active. The power pill time is null. Now I need a few functions that I will just define for now. This is for playing the sound effects of the game. This is for determining the end of the game. This is for checking the collision to see who eats whom. This is for determining the infinite loop of the game. This is for starting the game. Now, we finally connect the start game button. We have two entities in the game. One parked as Pac-Man. I create a file named Pacman. Just well, Pacman includes several properties and operations in itself. First, we define its class, then we go to its constructor. Its constructor receives speed and start position. Now, in the constructor, we need to define the following properties: position that it gets from the input, the speed that it gets from the input, direction, the limit is there. The power pill is false. We should set rotation to true. Well, initially we need to define a function to see if we are allowed to move or not. So don't move before the key is pressed. If I don't have a direction, then jump out. If the timer equals the speed, then reset the timer and return true. Otherwise, increment the timer. With this, we understand when it's time to move. Now, to move, we write the following function. Connect the movement to the current position plus the direction of movement. Do we collide with the wall? Here we check that for moving in a specific direction. There should not be a wall or ghost area in that direction. If there is, then the position should not change. And if everything is okay, the direction of movement along with the next new position is returned. We need to create the movements. We write a function, return the type of Pac-Man for the cluster remove and add. We will understand the reason for this later. Now we can get the new position with the following function. This character should be able to move with the direction keys of the keyboard. So I wrote the following function for it. Define a direction. If one of the direction keys is pressed, select the direction for movement. Numbers 37 and 40 are the codes for the directions respectively. The direction keys are also defined here in the direction setup file. If none of them were pressed, then do nothing. Now that we have taken the direction, if we have permission, we add it to the current position. Path check if we hit a wall, then load the new direction. Finally, we export it. And now let's create the ghosts. So they created a file named ghosts. Now I import the directions and types from the setup. I created the ghost class with its constructor. The initial speed is 5. It receives the start position, movement, and name as inputs to the constructor. Now I define the properties of the class in the constructor. Key, I get them from the input. I get the movement from the input. I get the start position from the input. I get the current position from the start position. The initial direction is to the right. I get the speed from the input. The initial value of the timer is 0. I say that the ghosts have not yet eaten their pill and are not scared. Rotation is false initially. The movement permission is exactly like Pac-Man. Now we need to write the next movements for this. For move algorithm here, the movement function should return the next direction and position, which is supposed to be completely random, which we will talk about later. This function will receive the position, direction, and existence of the object and will eventually return the next movement and its direction. Now we create the movement with this function. Like before, we get the time and name from the setup. Here we specify that if the ghost does not have a pill and is scared, what its type should be. And in the end, we will return them. And like before, we specify the new position. And finally, we export it as default. The movement of the ghost should be determined randomly. So I created this in a separate file named ghostMovement.js. Now I import the directions and object types from the setup. And now I need to write a function named randomMovement, which I export right here. This function receives position, direction, and object existence from the input. I assign the direction with this value assignment, mix the next movement with the current position and direction of movement. I get the direction key from the direction object. But here I start an infinite loop that continues as long as the ghost exists and does not hit a wall in this direction. Now I create a random number based on the length of the key. I replace the direction of this random number with a new direction and e.g. create the next presence here. And here I return to the next movement along with the direction. Now it's just time for the game field, which is one of the most important parts. For the game field, I created a new file named agamemesgameboard.js. In this file, I get some constants from the setup file. These include the size of the field, the size of each cell, the list of classes, and the types of objects. Now, I create the gameboard class with its constructor, the number of dots, which is the food of my Pac-Man, is initially 0. At the beginning of the game, we don't have any field. We need to use down for drawing. The first important behavior in the game field is the score. So first, we need to determine the status of the score. Create and show game win or game over. Create a div in HTML. Add the type of game status to it. Is here. I say if it has 1, write in win, otherwise write game over. Now I append this div to my HTML. Now we need to be able to create the game field at once in this class. So we define this method. Initially, the number of dots of foods is 0. There is no grid. There is nothing here my DOM. First, set the correct amount of columns based on grid size and cell size. Now, based on the grid size and the size of each cell or each house, I define ACS dynamically. Now let's draw a field. That is, the status of each cell will be determined based on the game level, which is a large matrix that we have defined in the setup file before. So I loop over the game level and consider each item as a cell. For the payment cell, I create an element asked on its type, which is in the class list in the setup file. I added the element to my HTML. Add here, I write its CSS property. Now I append and push it. Add dots. Now to the number of dots or foods, if it is food, I add 1 food. Any object in the game field can have 4 states. It can be added to the field, it can be removed, it can rotate, and it can exist. So for each of them, we need to write a separate function. Adding an object that gets the object class and position and adds it to the grid as a sprite in the array. Removing from the grid, that gets the position, and based on the type performs the remover, like the above method. Getting the object here, creating the character with this function. Styles, we can perform this rotation based on the input degree. Now, based on these drawing operations that we specify how the movement of the characters in the game field with a function. We get the character from the input, check if our character can, so if we can get the next position and direction of movement from get next move. So we just need to bind the current object to it for input. We get classes to a movie and classes to add from okay movies. If it should rotate and the current and next positions are not the same, then rotate. For rotation, we use rotative, which takes the next position, and character rotation direction is input. Now, after moving and rotating, it should return to its previous state. So, right, we move it from the current position, which I did, to the next position. Specify the new position of my character. Now, with a static function, I should allow the game field to be created. Create a new entity from the grid. Here, I created the board. Finally, I return the board. Almost. Now, we just need to write the main game index.js on start playing. I open the index.js file. First, we go to the play audio function to play the game sound. So I write which initialize a sound effect that creates an audio object in JavaScript, which takes a file from the input. And now I just need to play it. Now we need to write the start of the game. We have a function named start game. Now extend. First, the game starts music is played and its address comes from the setup. It's initially, we are not winners. We are not in attack mode on the ghost. So you don't have any score. Sufficient. Hide the start button. You pass the game level that we have specified to the game board so that the game board is initially valued. We disable the combo box for selecting the game level. We pass the speed and initial position of Pac-Man. Initialize a Pac-Man object. Add the type of Pac-Man to the board. Now, we need to say that it should be sensitive to the direction keys of the keyboard. And here we create 4 ghosts in an array with the ability to move randomly. An infinite loop in the game starts here based on the global speed. Now we need to determine the end of the game. So we wrote a function named GammaWeb. I started to extend it. Get the Pac-Man character and the game field from the input. The first thing I do is play the game over sound. Its address is now set up. I recreated the game field based on the game level that I had chosen. I bring my combo box out of the disable state because during the game we need to disable it. Now we need to remove the keyboard listener so that Pac-Man no longer moves with the direction. So now I pass the winner and loser state that I have globally to the show me statuses function. Now I need to clear the game interval based on the global timer that I have. Will show start button, and now in summing I need to show the start button for restarting the game. And now it's time for the infinite game loop until the game ends. Here we need to extend the game loop function for this task. Move Pac-Man. First, you need to say dash on a game board. The Pac-Man character can move. To check ghost collision on the all positions. Then we need to check the collision with the ghost, which we will write after this function. 3 more ghosts. Now with the loop, each of our ghosts we move based on the random property which they have. Whether a new ghost collision check on the new positions after moving, we check the occurrence of a collision. Now, we need to check if Pac-Man has eaten a dot or food in its movement. Check Pac-Man eats a dot. If it has eaten, we play the eat sound. The dot should be removed. And with remove that is a car. We add 10 points to our score for each dot. Now, we need to check if Pac-Man has eaten a power pill. Check if Pac-Man eats a power pill. If it has eaten, we play ASCII sound. That pill should be removed from its position. The scared state of the ghosts. Or in other words, this state without being shielded should be activated. Add 50 points to your score. We need to set the time for the ghosts to be without a shield. So that after a specific time that we have determined, the ghosts return to their normal state twice. Now, we need to activate scared state for each ghost. Change ghost scare mode depending on power pill. Now, we need to check if all the dots have been eaten. If all the dots are finished, Pac-Man has won. Check if all dots have been eaten. And finally, we announce the final score. Show new score. Now we are at the final stage, checking the collision of the ghost with Pac-Man. Before this stage, please subscribe to my channel so you don't miss my upcoming videos. Let's go to the last function, and then let's play an exciting game. Let's go. We have a function named check collision. Let's extend it. To check for a collision, we say if the position of ghost is the same as Pac-Man's, it means a collision. So for this, we use find on the array of ghosts. Now, we check whether collision has occurred or not. And if a collision has occurred, Pac-Man is in pill mode, play the sound of the ghosts being eaten, remove the relevant ghost, return the ghost position to its initial position. Now add 100 points to Pac-Man. In case of our collision, if it is not in pill mode, we remove Pac-Man. Set the rotation to 0. And we announce the end of the game. Well, before we dive into the excitement of experiencing the game we crafted together, there are a few components that we need to put together. Let's get started on defining some aspects before we embark on our shared gaming adventure. Alright, first things first, we need to export game bridges. Open the game bridges file, navigate to the end of the document, and export it. Now let's incorporate random move in this WordPress file. Okay, now we need to write the code for the game level selection combo box in the HTML file of our project. Open a HTML file, start by adding a label. Use the select at the HTML element with the item. The combo box. For the combo box, add 3 options with the names: easy, yes, medium, and hard. Sure, let's make that correction together. And let's go to the ghost/files file in the next move function. Instead of using get act move mobiles, that retrieves the position from the movement function and returns it. Let's change it to our next movie pulse in both places. Got it. Let's tackle the next issue in the Pacman's file related to direction. First, we need to import it from setup. Just after that, in the handler k input function, there's a change we need to make. We have to delete the directions here. See here. Let's finish up by making the final adjustments in the index. Just file. Just add a singles to the end of the last sentence. And that's it. Now with the command yarn start or npm start, we can play the game that we wrote ourselves. And here you go. This is the Pac-Man game that you wrote. Surprise! Yes, it's working. Now you have managed to write a game. Write a game in less than an hour, and many games are developed this easily with correct logic. Be sure to watch other videos and start to advance your programming journey with us. But if you want to improve your coding knowledge, check out our beautiful courses. If you are interested in web programming, check out our Next.js course. See you in the next videos. Enjoy your programming and happy coding.